Okay, so this video is going to be about angle relationships and the different kinds of angles. Our EQ is what are the types of angles and what are their different relationships. So make sure you get that down in your notebook. So an angle is created when two rays come together at a common vertex. So that can look like this. A ray with an endpoint meeting up with another one with the same endpoint, which we're calling the vertex. It could also be created by the intersection of two lines, where we have 4 different angles there. When we have angles that are made, we have 4 different kinds. We have acute, which are less than 90 degrees. We have right, which is exactly 90 degrees. And we have obtuse, which is more than 90 degrees. So make sure you're putting those different types in your journal. The last one is a straight angle. A straight angle is exactly 180 degrees. So we're going to talk about naming an angle. There's different ways to name an angle. The first way to name the angle is with 3 points. So we're going to start with A, the vertex B, and the other point over here, C. So this angle right here would be angle A, B, C. Notice that the middle letter is the vertex. So you could also name this angle C, B, A, where B is still the vertex, still in the middle. So first you can name it with 3 points. Another way to name this angle is with the number that's being denoted within this angle. So I could also call this angle 1. If you look to the right, I have 2 lines being intersected with another one. So I'm just going to pick this angle right in here and name it. I could name it angle APC because P is the vertex. I could also name it angle CPA because P is still the vertex. I could call it angle P, but if I just refer to it as angle P, I don't know if I'm talking about the angle here, the angle here, here, or here. So we don't really want to just use the one letter. We want to use all 3. The next thing we're going to look at is adjacent angles. Adjacent angles share a ray and a vertex, so they're right next to each other. So I could have this angle here, and it would be adjacent to this one over here. And I'm just using angle markers to show that there are 2 different angles there. Here in the middle we have the angle addition postulate, which means if I have 2 adjacent angles, if you add them together, you can add their measures together. So down here we've got an example where angle EFH is 35 degrees and HFG is 40 degrees. So using the angle addition postulate, I can add 35 degrees and 40 degrees to get the total measure of angle EFG, which would be 75 degrees. So those 2 adjacent angles, I can add them together and get that whole measure. We're going to step it up just a little bit and have some algebraic expressions as our angle measures. So the total angle measure is 120 degrees, so I know that this whole thing is 120 degrees. And since they are adjacent angles, I can add the 2 angle measures up. So I would have 2x, which is the measure of angle ABC, plus 5x minus 6, which is the measure of CBD. And I know that it's going to equal the total angle ABD, which is 120. So we're going to use some of our algebra skills, combine like terms, 2x and 5x to make 7x, minus 6 equals 120. Then we're going to add 6 to both sides, and I get 7x equals 126. Divide by 7. And I'll have to do some long division. No calculators. So I get 56, so that is 18. So the value of x is 18. Oh, but it asked me to find the measure of ABC and CBD, so I'm going to have to plug that in. So for the measure, notice I'm putting M of angle ABC. It's 2x, so it's 2 times 18, which is going to be 36 degrees. And then the measure for angle, what is it called, CBD, is 5x minus 6, so 5 times 18 minus 6, let's see what 5 times 18 is, 90. So 90 minus 6, which is 84 degrees. So I've got 84 degrees and 36. And just to double check, I can check my work and say 84 plus 36, and that should equal 120, which it does, so we're good. Okay, so we're gonna go on to our next topic. So on this screen, we are being asked how many degrees does the measure of angle 1 plus the measure of angle 2 have, and why. So the measure of angle 1 is over here on the right, and the measure of angle 2 is much larger. But they are adjacent, and when they are adjacent and they make a straight line, they have a measure of 180 degrees. So angle 1, measure of angle 1, plus the measure of angle 2, in this case, since they make a straight line, is going to equal 180 degrees. And they have a special name, and we'll talk about it later on in the video. So we have some different relationships for these angles. So the first one we have is vertical angles. And I'm going to start by drawing the picture. So vertical angles comes from the intersection of two lines or two line segments, and they are across from each other. So this angle and this angle, I'm going to use colors to mark them. The red are both vertical angles, and then these pink ones here, these are vertical angles. So let's write a little definition. Vertical angles, I'm going to say vertical angles are opposite of each other. And I'm also going to say that they are congruent. They are equal in measure. So they are congruent and they're opposite of each other. The next one we have is supplementary. So that's kind of like the picture that we just saw, supplementary. So it could look something like this, where they are adjacent and they're making that straight line, because remember, supplementary is going to equal to 180. So if this was angle 1 and this was angle 2, I could say angle 1 plus angle 2 is equal to 180 degrees. So I'm going to write that in my definition. Sum to equal 180 degrees. The picture on the right, it could also be called a linear pair. So I'm just going to put little quotes under here and put linear pair, because they come together and they make a straight line. So we could call it a linear pair. The third one we have here is complementary. So complementary is going to be something like this, where we could have adjacent, they don't have to be adjacent angles, but they come together and they make a right angle, which is 90 degrees. So in this case, if I had angle 3 and angle 4, they would equal 90 degrees. So I'm going to say sum to equal 90 degrees. We have a couple other vocab words down here. Congruent. So just remember that congruent means equal. Or we could even say equal measure. So the measure of the angles would be congruent. They would be equal. Bisector, that means cut into two pieces. I'm going to say two parts here. Cut into two parts. So if you have an angle that is being bisected, it's being cut into two equal parts. So we've got some examples to work. 4 examples. For number 1, I have these two values 5x and x plus 16. Those are vertical angles, so we are going to set them equal to each other because those two angles are congruent. So I'm going to say 5x is equal to x plus 16. And all I'm going to do is use a little bit of algebra, combine like terms to solve for x. So subtract x on both sides, and I get 4x equals 16, divide by 4, so x is 4. Perfect. I'm also going to label what kind of problem this was. So this was vertical angles. That's my shorthand for angles. Move on to number 2. So number 2, we have adjacent angles that make a straight line. So that means they're going to be supplementary. Supplementary angles. And supplementary means they sum to equal 180. So all I'm going to do is take the two expressions, add them together, set it equal to 180. So 7x minus 32 plus 3x plus 12. And they're supplementary, so they sum to equal 180. Again, using our algebra skills, combining like terms, 7x and 3x makes 10x. And I have minus 32 and plus 12, so that's going to give me a minus 20 equal to 180. Combine like terms, move the 20 over. And I get 10x is equal to 200, divide by 10, so x equals 20. Perfect. Move on to example number 3. I have two adjacent angles that are next to each other, and they are making a right angle, which means they are complementary. I might have spelled that wrong, but we're just going to go with it. So we're going to add them together, and they are going to equal 90. So 5y plus 1 plus 3y minus 7 equal to 90 degrees. So 5 and 3y makes 8y. 1 and minus 7 makes minus 6. I'm going to move the 6 over, and I have 8y equals 96 divided by 8. So y should equal 12. So y equals 12. And I've got my last example over here where I have a combination. I have a set of linear pair or supplementary angles, and I also have vertical angles. So if you look at the angles that are vertical, I'm just going to highlight them. We have 7x plus 10 and y. So if I wanted to, I could say y equals 7x plus 10, but that's not going to help me figure out what x or y is. So instead, I'm going to start with 7x plus 10 and 3x because they are going to sum together to equal 180. Those are my supplementary angles. So 7x plus 10 plus 3x is equal to 180 degrees. 7x plus 3x is 10x plus 10 equals 180. Subtract 10 to get all of my numbers together. 10x equals 170. Divide by 10, and I get x equals 17, which is great. That's half of my problem. I have x equals 17. So there's a couple things I could do. I could take the x equals 17 and I could plug it in here, and I could do 7 times 17 plus 10 and set that equal to y to get my answer. I could also take and plug in x right there, 17 times 3, which would make part of this linear pair or supplementary angle set right there. So either way, you're going to get the same answer. I'm going to use the linear pair. No, I'm going to use the vertical angle since I already used a linear pair. So I'm going to say 7 times 17 plus 10 is equal to y, and that's how I'm going to figure out what y equals. So 7 times 17 is going to be, oh, I don't know, do a little scratch work. 7, 8, 9, 10, 11, 119. So I'm going to have 119 plus 10 equals y, and 119 plus 10 is 129. So y is going to equal 129 degrees. So main ideas for this video: supplementary angles, vertical angles, complementary, linear pair and those relationships.